Welcome. My name is Adam, and we're going to be, and I'm joined by Jessica Hexel. We're going to be doing an overview of the IT Fundamentals course offered by cyber.org. Today, a couple of things we're going to be doing. We're going to introduce ourselves. We're going to introduce cyber.org. We're going to do a couple of lessons that are going to involve hands-on labs. And then we're going to talk about how important the troubleshooting methodology is to this course and the students and getting the ITF certification. And so that's just kind of a schedule and how we want to break it down today. Our goals, we want to introduce ourselves and who we are. We want to talk about the course itself, the grade bands it's effective for, the certification attached to it, and then any kind of technology requirements for teaching this course. And then we're going to kind of do an overview of the different lessons and labs and different resources that are available to you. And then we're going to demo some lessons. So who are we? This is kind of exciting. I finally have a fun picture. I've been working, my name is Adam Topher. I've been working here at cyber.org for just over a year. It was a year in February. I have a background in teaching. I taught for about 6 years. I taught English in Japan, and then I came back to America and I taught English here. And then I moved to Texas and taught technology, specializing in like networking and becoming network technicians. So we specialized in the going from A+ to Network Plus at our school. And I have a history, a background in networking and server administration. And that's kind of what brought me here to cyber.org, was my background in technology and then also teaching technology in the classroom. And then joining me today is Jess. She's new here at cyber.org. Do you want to introduce yourself? Oh, I could hear you earlier, but now I can't hear you.
Okay, now you can hear me. All right. The interface was saying that I was not muted, but my headset was saying I was, so I was confused for a second. All right, hi, I am Jess Hexel. I am new to the cyber.org team. I've only been here just over a month. I have a background teaching math and computer science in high school in California. And in 2022, I was an Einstein Fellow placed at CISA, the Cybersecurity and Infrastructure Security Agency that supports cyber.org. And then I took a year off. And then when I was looking for what was next, I found cyber.org, and that's happy to be here.
And we're really glad to have you. So cyber.org itself, we are part of the Cyber Innovation Center. We're the academic initiative of the Cyber Innovation Center here in Louisiana. And cyber.org believes that K-12 cyber education is the key to solving what is currently the cybersecurity workforce shortage in the United States of America. Us partner with CISA and DHS. Our goal is to empower educators and help bring up a workforce here in America from the K-12 classroom. So we want to provide cyber education resources, and we want to build an education pipeline to support K-12 educators and build basically a steady stream of students to prepare to enter the cybersecurity programs and jobs. And through like what we're going to be presenting today with the ITF, we have curricula that offers certification that students can come out of high school and be certified, ready to approach the job market. And it's really amazing. It's something I wish that we had whenever we were in school back in the day. It's lovely, and it's all free, and that's the best part. The fact that there's last time I checked, almost 500,000 job shortage in America, and then now we are working to build the pipeline to help solve that shortage. Now, people ask, what is a CTE pathway? This particular course that we're going to be talking about today is the IT Fundamentals course. It is the beginning of the pathway. And this particular course is also only a 1-semester course. So a lot of schools, they operate off of a 2-semester are 1 year course and a 1 year structure, and so this would only be half of a year. We have a new course that's coming out this next year, next school year, called Intro to Linux, and that is also going to be only a 1 semester course, and it would pair perfectly with IT fundamentals, and that would allow you to have a full year course load. And technically, students could actually be ready for 2 certifications in that instance. So for it, you could start the year with IT fundamentals, build up all the necessary knowledge to get ready for a cybersecurity course, and then take a certification. And in the second half of the year, they could do the Intro to Linux course, and by the end of that course, have a second certification, but also have all the background Linux knowledge to help them in their networking and then cybersecurity course as well. And all 4 of these courses are offered here at cyber.org. Now, the ITF Plus, this is a test that is aligned to CompTIA's FC0U61. This test has actually gotten quite old. It launched in September 2018. And if you're familiar with the Security Plus or the Network Plus, these always renew every 3 years. And a student who were to take one of those tests, their certificate or certification is only good for 3 years as well. This particular test, though, is good for a lifetime. It covers concepts like infrastructure, technology, all the terminology they would need to know, applications and software, hardware, security, everything necessary to get them started on the pathway to networking and security. There's no experience necessary to take the test. Unlike the Security Plus, usually there's 1 to 2 year experience recommended for taking that. This exam is also cheaper than most of the other exams. It runs about $134, but there are, of course, vouchers and discounts that you can get through your school or through CompTIA. And this test is approachable for most students. So say, for instance, the A plus takes sometimes more than a year to study for on the school level, right? It's a lot of material. The Security Plus is complicated. So we normally say it's something to approach in the 11th or 12th grade. Same with the Net Plus. This test is more approachable from, say, the 9 through 12. And it's easier for students to grasp a lot of the material. So why would you want to implement this? Well, a lot of bonus points for school performance scores, because this is a industry certification. And so if you get your school will get points based via these industry recognized credentials, points towards schools accountability ratings. Most schools, you can get money for every student that obtains a certification. And of course, almost every state, right, has a course or course code or some CTE course written for one of these exams. Now, the last bullet point is actually the most important, in my opinion. While it's outside of the school and you're not getting CTE course credit for this, most colleges, their entry level, say 101 type courses, usually teach towards the ITF plus, depending on which curricula you're going towards, right? And a lot of colleges will allow a student who has the ITF already to CLEP out or test out of a course. So if you can prove that you already have this exam, you've taken it and you've passed it, then you can go whenever you go into college. If you're going in this direction, you can say, I already have this exam. And so then you just test out of that course. So that's saving students money in the long term. That, to me, is one of the biggest benefits, to help the students whenever they go into college. Now, I mentioned it earlier, but one of the biggest deals, of course, is our no-cost cybersecurity resources. So if you have not signed up, I saw Jessica put a link in the chat. That link for curricula access is the same as this QR code. So if anybody has not followed one of the links in the email or just has not signed up yet, this is where that takes you. If you don't have access today, that's fine, because you won't really need it. I'm going to show you all the important parts today, and then we're going to share everything that's necessary. So no reason to stress it for now, but this will take you there. And then this is what the course actually looks like. So I guess what I'm going to do is I'm going to go ahead and present, because this will actually, oh, hold on. Let's just, of course, it's not gonna, I forget it's not going to work. It's going to show the other screen. I'm going to leave it like it is. Sorry. What I have here boxed are the important parts I want to talk about. I'm going to pull it up on just a second on the actual website. But the course has a few different things that are important to teachers. And whenever you want to teach the course in your classroom, we have a syllabus example for you, and that you can hand out to students or to parents who want to know what's going to be taught in the course. We have an example that you could look over and then even rework for yourself to hand out. Every lesson has a few different things in it, and then some lessons do and some lessons don't have it. So every lesson has teacher notes. These are the ones that you can go through and look through and see how the course, how that lesson's taught. Everyone has a PowerPoint that you can work through and you can put on the screen and show the students how it goes. There are guided notes that you can hand to the students that they'll be fill in the blank style notes that they'll work through, and that can be your exit ticket, or that can be just how they proved that they were following along for the lesson. And then, of course, we have an answer key that goes along with the guided notes. And so that helps the teacher see the exemplar answers and how the answers should look. Now, for the scenario, not every lesson has a scenario. We're actually going to go through this particular scenario today, but every lesson does have a quiz and a key. I'll pull this up in a moment, but I want to keep moving just a little bit, and then we'll go to the actual website and I'll show it to you guys. So one of the basics of IT fundamentals that it kind of builds on as the course gets further and further progressed is just the basics of computing. And one of the reasons I love this is because of the gift that comes at the end, and I love showing that. But it starts really simple. In ITF, it talks about, what's a computer, what are the functions. We talk about input, storage, processing, and output. And when I used to teach this, I always found it fascinating because I would start this at like 8th grade level. And we'd have a lot of fun with things like input and output. What is input? What is output? And so I've always had a lot of fun with that in the class. We'd play games. We did Kahoots and things like that, just to have fun with it. So input, we know there's something that gathers information. So things that students often don't think about when it comes to input are our webcams. So our keyboards, our mic, that's what we normally think about. But cameras, microphones, things that are kind of outside of what we normally talk about, like our trackpad or even a touchscreen, can be both input and output. Our storage is both our RAM for memory or our hard drive. When it comes to processing, this is our central processing unit, does all this stuff for us. Oops. And then our output. This displays all of our information in a variety of ways. And when it comes to output, I always had students in the past that would get focused on the monitor and what they're seeing. And so when they start thinking about headphones and speakers, students would always get surprised. Oh, yeah, that's true. That's output as well. Or a printer, for instance. And then when I just always thought this GIF was really interesting because it talks about computing and processing, and then it just kind of shows you how it all works. So I just think it's really neat. So before we get into the lab, I want to open up the actual course. Now, to access this, all I did was I came into, I'm gonna go ahead and close this. I'm just gonna open up the Canvas. So my name and password is remembered here, but we refreshed Canvas a while back. so that everything is broken down into grade bands. So to access this, you just go to https://cyber.instructure.com. Go ahead and type that in. If you have access to it, feel free to access it now. If you don't, that's totally fine. I'm just going to show you where it's located. That way you can pull it up. But what I'll be showing you will be on the screen, and you'll be able to get to it that way if you need it. And then this particular course will be accessing IT fundamentals. I already have it pulled up, so I'm not going to click on it. But this is the course. Now, there are two ways to look at this. We have currently on our home button, we have it laid out in the way that we think is a logical way to teach it. When you say access denied, the course says access denied or accessing the actual website? So like if you click the link that I shared, it doesn't take you here, it just says access denied. IT fundamentals says access denied. That's very interesting. Do you have access to any of the other courses? That is very interesting. Okay. Well, I'll tell you what, I'm going to write down your name, and then I'm going to ask somebody when we're done for some details on that. So I'll be getting back with you. And then I have your email in the list of the people who signed up, and I'll check into it and I'll get back with you. Okay. Sorry about that. So this course can be broken down in one of two ways. Currently, it's like most of our, not I say like most, that's not correct. Some of our courses are set up that are CompTIA courses. So this applies to CompTIA courses. This is what we consider our logical teaching order. So you'll notice that like the very first lesson, troubleshooting, is 1.6.1. That's CompTIA's objective 1.6.1. And then we have binary 1.1.1 under Unit 2 programming. If I click CompTIA fundamentals objective order, it'll change, and then you'll see everything in CompTIA's objective order. Can you teach it this way? Absolutely. We just have it set up that in a way that we think is a logical way to approach it, because one of the most important things that happens throughout this whole course is the troubleshooting methodology. And if you approach that first and then you think of everything else with that in mind, it helps. But how you want to approach it, that's totally up to you. Like all of our courses, this course is modular. So if you only wanted to teach the troubleshooting methodology and teach nothing else, you can do that. It's totally okay. But what I wanted to point out earlier, that not every course has, this particular course has a scenario. This particular lesson, sorry, a 1.6.1. But if you notice 1.1.1, it does not have a scenario or lab. 1.1.2 has a lab, and that's actually one that we're going to be doing here in just a moment. So I just wanted to point that out. All of them do have teacher notes. All of them do have PowerPoints. They all have guided notes and answer keys, and then they all have quizzes and then a key for the quiz. So the quiz can be anywhere from like 4 to maybe 10 questions, and that we have that for every lesson. We don't have unit tests, so it's kind of up to you to make a unit test for this. We do have unit lesson plans, which actually I can actually pull one up for you. I hadn't downloaded one of those. So this is our unit lesson plan, kind of what it looks like. Shows you an overview, shows you the objectives for the unit, what grades it's appropriate for. It says grade level 8 and 9. You can teach this to 12 if you want. It's not a big deal. We just don't normally recommend it for 6 and 7. Although I have taught this to 7th graders. Excuse me, sorry. And then it talks about the different topics that it's going to approach. And then it goes through each pre-launch. And then there are actually scripted parts of this. Not all of our CompTIA courses are scripted like this. So like ask the students, have they written any code? And then getting into the lesson. So it's pretty well developed. And then there's also a career spotlight at the end of this, which for this particular programming would be a software developer. And if you've never seen them, our career profile cards on our website, really neat. There are printables for these. So for instance, you could download the poster or the card. If you wanted to post a career developer software developer, on your wall in your classroom, you can print these and post them up on your wall, and they're really, really pretty. And we have card packs for these as well that have all the different cards. Okay, anyway, sorry, getting a little sidetracked there. But our teacher notes, I wanted to just pull those up right quick, and the guided notes. Here we go. So this is a teacher note for this particular lesson on binary. It talks about the connections being hardware and software. And then your overview, you're going to compare and contrast notational systems. So for those of you that have to have I forget what they were called, what we used to call them, but you'd have to have an objective written on your board. This is kind of where you can help create your objective for the day on there. And then this breaks down, it talks about the objective from CompTIA, any terms you're going to use, and then it gets into binary, what binary is. And then the other download was the guided notes. These are the questions that the students will answer along the way in the lesson. And then one more thing we can open up is the PowerPoint. That is the wrong one. Let me go back. Oh, because I clicked the wrong one. That's why it's the wrong one. Sorry. Yeah, so binary. And then, so it talks about it. And then it talks about just this little joke at the end of this one. Okay. Okay, here. So now let's go ahead and break into our lab. We're going to share a link in the chat, and this link is going to take you to a Google Sheet. I'm going to go ahead and open it. This Google Sheet is a live document, and what I would like you to do, if you would, pick one of the teachers and then put your name next to it so that we know which one you're going to use. And this is going to take you to the range. So I'm going to switch now to the range classroom. This, if you've never seen our cyber.org range, this will be a fun experience. And so, sorry, I'm just looking at a message. And so, what we're going to do, you don't need the range for this particular course. But today, for the benefit of all of us being able to work through the lab in the same location and using the same tools, the range makes this easy. So what I'm going to do, I'm going to launch for everybody the same machine. Select all. And that way we're all going to be able to use a Kali Linux machine. Was everybody able to access that Google Doc? It should be shared for anybody to be able to access, hopefully. Oh, is it editable though, I guess is the real question. I did not consider if it was editable or not. Can anybody edit it? I did not test that outside of myself. I didn't think about that. It looks like I see anonymous elephant. That's good. They can click on it, but I don't know if you can edit it or not. This is what happens whenever we jump into a live recording and I did not test other people being able to edit it. Oh, perfect. I see names popping up. Wonderful. I was getting a little worried. Okay. So what you do is you'll pick a name. You'll pick, yeah, I'm sorry. Use your name. But wherever you put your name, you'll see three things here. One is a nickname. The nickname is not super important. It's really kind of only important to me because then I know which of the slots you're using. Next to that is a username. The username is important and the password is important. So here's where you're going to use that. Let me open a new window and I'm going to go to apps.cyber.org. This is where I want you to go to. If you have already applied for and received access to the range, don't use your own personal account today. Use the one that's on there. So you would click login and you would use that username that's here. So I'm going to say pick one that's nobody's using, test. And I'm going to go back to that thing. So here on that test one, let me highlight the whole row. Sorry. I would put, for instance, EZ8MKEA, and then password is I, capital T, capital F, UN. Now, you don't type this exact thing in because I'm using, for example, line 28 is teacher number 6. I put test on there. You would use whatever your username on the line you chose is and the password. Is that make sense to everybody? Hopefully. So for instance, Lakeisha, I hope I'm saying that right. You would use the username that's there, FSUA62D, and the password is exactly the same as the password I just typed in on this one. When you click login, it should look like this. You see that the classroom is Topher, that's me, and that you already have a machine booted. I see 2 people in there. Carlos, are you able to get in? If you don't want to participate, that's fine. You don't have to. So it's a kind of a low pressure, not a big deal. But if you can participate, it will help in case you do run into an issue. It's good practice. Okay, Lakeisha, you got in. So I'm gonna go ahead and hope that others are also getting in. If you're not, raise your hand or just ask a question in chat and we'll see if we can help you out. For now, I'm gonna go ahead and close this window so that I can keep moving. Okay, so I'm gonna do this from my machine because my machine is gonna be the same as yours. What we need to do here, what you're in, okay, I'll explain a little bit. One of the keys in this particular course is not the cyber.org range, and this particular presentation we're doing is not the range. It's just something that we're using today. It's like a bonus feature, right? We have a range, if you've never heard of it, that has 4 different machines on it. Today we're using the Kali Linux machine, and then for all intents and purposes, it's just a Linux machine. So that's how we're going to use it for today. Now here, we're going to open up a terminal, which is this black box on the top left. And that's going to allow us to type in command line. So all I did here was in the top left of the window, on the toolbar, there's a black square. I clicked it and it opened up the terminal. Now from here, I'm going to install, or I'm going to update the apt repository, and I'm going to install Thani. So if you want, I can put the instructions back up here. Using that, the first thing we're going to do is type sudo space apt space update. So I'm going to do that. Let me do control, oops. Make this a little bit bigger, so it's easy for you guys to see. Hopefully everybody can see that pretty well. So I'm going to type sudo space apt space update. What this is going to do is update the database that the system pulls from. I'm going to press enter. It's going to do a whole bunch of work. It's going to take it a few minutes, not a few minutes, a few moments to update. If you try to just install Thonny, it might work, but it probably won't pull the database for it because the database is not up to date. So if you update it first and then install, it'll have everything it needs. So now that everything is updated, we're going to sudo space apt space install space Thonny. And we're going to add -y. Y. Let me type the command in chat. Sudo apt update sudo apt install Thonny -y. I'm gonna go ahead and hit enter. Now what this does, the -y, I'll do it without the Y. So you'll see. When you try to install it, it's gonna ask you, do you want to continue with this operation of installing and adding data to the system? I'm gonna type Y and I'm gonna press enter. If you did the first command that I typed in, which was that plus the -y, it just automatically prompts the Y. It'll add the Y to any prompts that pop up without you having to type it in. That was the only difference. Now this will take a moment because it has to install it. So if you did it with -y, you would have noticed that you didn't have to type that Y like I did. It's going to be the longest part of our lab, the installation of this. Everything else is, it just goes as fast as you type. And this takes a moment. Hopefully it's working for everybody. If you do have a question, though, let me know. I'll be happy to pop into your machine and help you at any point in time. Now, what's going to pop up here, it says there's a new version of OpenSSH server, and how do you want to configure it? If you hit enter here, it's going to say, do you want to keep the local version? Yes, that's fine. We're just going to hit enter. That's going to keep moving. Sorry, mine looked a little weird because I had zoomed in on it earlier, but it should be better now. When this is done, we're going to okay, I see you're saying you have to do this separately anyway because you have to check all installs with your district office. MSD training them on this in 2 weeks. So here's the thing. None of this is being installed locally on your computer. So that's fine. You can check with your district about that. But a lot of people that use this are using this mostly because they don't have to do that. Does that make sense? So what you're doing right now, so at face value, if you look at this lab, it tells you there are 3, like I can actually do that. Let me go pull up the actual lab. On the actual lab, it gives you 3 options. You have an option to install Thonny using Windows. Go to the website and install it on your computer. Oop, I just unplugged my monitor. Sorry. I had a feeling that one day that would happen while I was doing a presentation. And today it happened. And I'm not sharing anymore. Let me try again. Okay, so can you see my screen? Sorry. Um, it's now upset
Yes, we
because
can see it again.
there we go. Now I came back. It was the second screen took a moment to come back. Anyway, so what you see here is the installation instructions for Windows. And then there's also installation instructions for Mac. And then of course, installation instructions for Linux. Of all of these, the easiest one to install is Linux because all you're doing is just typing the instructions and then launching it. But the any of them will work. And a lot of the screenshots in this particular course are from Windows 10 because the course was written a few years ago. But you can do this if you want to install it locally and your district does approve it, then you're welcome to do that. But today, the reason we're doing this in the range is so that we can all troubleshoot at the same time using the same thing. Hopefully that makes sense. And that's why I chose to do it in the range. That way, say for instance, if somebody here was using Windows 10 and I'm using Windows 11 and one person had a Mac, we'd have to troubleshoot all these different things. And we eliminate all that by all doing it in the range today. This course wasn't created with the thought process of using the range, but it works just fine in the range. For some of these anyway, for Thonny's great because Thonny works really well in the range. Not everything works in the range, but this does. Okay, so all you gotta do is type Thonny. If you didn't do it because you were afraid to install it for your district, that's fine. If you want to catch up, it happens really quick. It's just a matter of those 3 commands. And then Thonny should have already been in the chat. Okay, so all you gotta do is press let's go and it'll get it started. Okay, so this takes us to the next step. Now we are done technically with the first lab, which was installing Thonny. The next lab is called Basics of Computing, which just talks about input, output, and storage. And we're going to work through all of that with this particular lab. So what we do I guess I'll go ahead and present this again. This talks about an example called x equals input, and then we're going to save it, right? So that's what we're going to do. In that main screen of Thonny, we're going to type x equals input. So here, x equals input, and then open and close parentheses. So if anybody here is familiar with programming Python at all, these are all going to seem extremely simple and familiar. A lot of that is what we're going to be working with today. So file, save as, and then anywhere you want to save it is fine. But we're just going to call it basics of computing -py. And then I like to save things on the desktop in Kali because it makes them easy to find and access later. And you can also notice in the background, everything you're doing in the program is happening on that terminal, in case you wanted to point that out to students. Now, on this program, in order to get things to run, you need to press this green play button. So to run this script, we're going to press play. And then you should see down in the shell, the bottom part of the program, you should see a cursor blinking now. So what we can do, we're going to type the word penguin and press enter. And what this has done, penguin was technically our input. We've put that in as X. So it stored it. It was just very simple. It stored whatever input we put, it stored that as X. And so from now, we're going to get a little more complicated after that. But one of the most important things to know is that this little green button here is what causes this to run. So now we're going to add some extra things to this. We're going to add another line. We're going to type print X. So this way, whatever you put in as your input, it's going to print that input to the screen. So if I press play and I type penguin again, it's going to return penguin to the screen. So now we know that it's working. We know that it's taking whatever we're typing, saving it as X, and now it's printing whatever that X was. So you could type whatever you wanted. It doesn't have to be penguin, but it is taking an input and it's giving us an output. So we've proven those two things. So now let's make it a little more complicated. We're going to here, excuse me. Oh, well, I guess I shouldn't have done that. I should have just made a new line. X equals, we're going to add a word. Let me go back to that, putting that print on there. And I'm going to explain this. Okay, so if you weren't like me, you didn't delete your print line. We put between the input and the print X, we put a line that says X equals, and then the word in with a tick, emperor. So it should look like this. I'm gonna go ahead and type it in the chat. X equals input, open close parentheses, X equals, and then a one, not a quote, but like a single quote, emperor, space, close quote, plus X. Then the next line is print, open, X, close. And then what it's going to do when we press play here, it's going to ask us for an input. So we're going to type penguin again. And then the output is going to be emperor penguin. So all we're doing is now manipulating the output by adding text before our input. So now in the lesson itself, the original lab, what we're saying here is that there's 4 basic steps. What are the 4 basic steps? We have input. It was stored as a variable. The variable is processed by adding the word emperor to the front. The script asks for the input and uses the types to send the input. And then, of course, there's output with the print function, right? So now there's a different script we can type in here. And we're asking, what would the following script output if you input the number 5? And if you can just read that and understand it, that's great. But if you want, we can easily type this in, and then we can figure that out. So I'm going to go ahead and type this in chat. Enter a number, and then number is your variable that you're giving in here, and then integer input num equals num times 2, print that number doubled is, and then comma num. Okay, so you can put that in. I'll just replace that in mine right quick. I want to show you how to copy paste, because this is the question is going to come up eventually. Here, if you press in your VM Control Alt Shift, it'll bring up this little clipboard on the left hand side. This does a lot of things. This allows you to zoom in on the website. This also brings up a clipboard. And so here I can paste, and this puts it in the clipboard for the actual VM. So then I highlight what I want to copy, and I copy it, and I come Control Alt Shift again, and here I paste. And now it's in my actual computer. So the way I did that is I Control Alt and Shift all at the same time, and it brings up that clipboard on the left-hand side. Probably one of the handiest parts of using a VM. Now, if I press play, it asks me to enter a number, so the output is there. Press 5, give it an input, and it says that number doubled is 10. Is this everybody able to follow along so far? Hopefully I'm not moving too fast. But I wanted to show that copy and paste function as well. Not that it's necessary for this. The range is also not necessary for ITF. It's just a tool that you can use As like Kathleen mentioned, it's helpful if a school system does not want you to install Thani for students to be able to work with Python. This circumvent, not necessarily circumventing the school's install stuff, but this just makes it not necessary to install on a school computer. You also can't break anything. If you want to know more about the range, we do have some workshops coming up, and I'll talk about those later. Next thing we want to do is make this a little more complicated. So here I have a couple of things here. I tried to present this earlier and it didn't like when I tried to do that, did it? What is the input stored as in the last script? It's stored as a what? So we gave it input in our here I have it and move it a little bit. Oh, I had it. So on here, you feel free to type in chat. And then of course the code is in the chat as well. How did we store our input here? Anybody want to take a guess before I reveal it? Nobody? Okay. That's fine. This was stored as what's called num, right? We called it that. We called it a num. It's a number. It was also an integer. What is the processing line? Well, it's processing here as num equals num times 2. So you're giving it a number, and that number is being multiplied, and then we're giving it something. So which line is the output line? Well, it's kind of easy to know because here it says print, right? I can bring it back up here. These two lines are output because they say print on them. Okay. So here's what I want to see if anybody here can do. We want to make 2 programs. We want to delete that and then try to make a program. There's two things here we want to do, and we're going to take a little time to make them. We want to ask someone. So you want to use the print function to use 2 numbers and multiply those numbers and then display the results of those numbers. So this is a question that we would give to kids in a lab. And then we want to ask a user for their first name and their last name, and then have the script say, hello, so-and-so, with their full name. So if you want to try either one of those, and if anybody wants to show how they did it, that would be awesome. But if you don't feel comfortable doing that, then I can do that on the screen as well. Okay, I'm going to go ahead and show the number multiplication one as a way of possibly doing it. So once again, the print, because you want it to print to the screen. And then for a string of text, you always surround it with a quote to open it. So enter 2 numbers. Oh, that's numbers. Yeah. And then we're going to close the parentheses. And then on the next line, we're going to need to be able to store one of the numbers. So we're going to give it num1 and then equals an integer input, and then num2 equals integer input, and then num3 is going to be num1 times num2. And so this is the mathematics. This is how you get the multiplication of those 2 things. And we're going to print to the screen those numbers multiplied equal num3. And so if I run this, hopefully I did it all correctly. Enter 2 numbers. Let's just say 4, 2. And those 2, so I press 4, press enter, or press 2, or press enter, and those numbers multiplied equals 8. So all it did was it stored number 1 as the first one I entered, number 2 as the second one I entered, and both of them are stored as integers, meaning they're numbers. And then it just said those multiplied equals, and then you told it where to put num3, and you told it how to do the math on num3. Now, for instance, if you chose the name, that particular one was print, same as before. Enter your first name, close quote, close parentheses, and then F. I mean, you could change this however you want. Once again, this is one of those things where there's multiple ways to do it, but F name could stand for first name equals input, and then print, enter your last name, and then this input would be L name equals input, and then lastly print hello space, and then close parentheses, and then here you're going to put F name, L name. Now notice I made a typo here, right? And close parentheses. Now this typo that I just made before I went to fix it, this L name has no association with anything. So if I try to run this, enter your first name, Adam, enter, last name, Topher, enter, it gives me an error. So if a student were to say, oh, I had an error, I don't understand, I did it exactly as you told me to. Well, the error here says L name is not defined. And of course, I did define it. It says L name here, but notice here's a lowercase and here's an uppercase. So this is just kind of an idea that you can help troubleshoot. It does help you troubleshoot it. Oops, I did not mean to do that. So if I press play now, I should be able to type my name, Topher, and then it'll tell me, hello, Adam Topher. So hopefully that was helpful. Oh, oh, I just heard they're testing the fire alarm system. I didn't realize they were doing that today. So hopefully it won't interrupt us too much. Okay, next. The next thing I want to talk about, and for now, actually, we can close this. The easiest way to close it, if you hit close at the top, it'll close your window. And then for you, logged in as a student, you can actually close your machine. You should have an option to close. In a classroom, if you have a classroom of these, they automatically close. So if I hit edit, it'll show me. They automatically close at a certain time. For everyone in this classroom, it'll close at 3:59 Central Standard Time. But as a teacher, if you have a classroom of these booted, it saves us a few pennies if you close them whenever you're not using them. So you can hit terminate on yours. It's helpful. I'm not going to terminate everybody's right now, because if you want to use them for a moment, you can after we're done. And then they'll automatically close an hour after this presentation is finished. Okay, so one thing I want to show, one of the most important things to this whole course is the troubleshooting methodology. And this appears in the very beginning of the course, and it's reiterated upon multiple times. So with us, I want to spend the next few minutes going through this, and then we're going to use this to troubleshoot a presentation. So we're going to talk about one of the first scenarios, and then we're going to use that troubleshooting methodology to go through that scenario. And if anybody has any input talking about the scenario, it'd be fantastic. And if not, that's fine. But the troubleshooting scenario, and I feel strongly about this as a person who has a background in IT and troubleshooting and being a tech. When I first started teaching this, knowing that students were going to need this in the field in the future if they wanted to be technicians. I know how important this is to them. And I also know that on the actual test, the ITF plus CompTIA really nails home this troubleshooting methodology. A lot of the questions focus around the theory, like theory questions. So it would be like we're going to see in our lab, or our scenario. Sorry, how would this happen, or what is the cause of this? Those kind of questions. So I'll show that in a moment. But the majority of the test, if you've never taken the ITF plus, is questions regarding around this, and so that's why I like to really hammer it home. So basically, the troubleshooting scenario is when something breaks, what are the appropriate steps to fix the problem? And excuse me. What we want to do is we want to identify the problem, research the knowledge base or the internet. We want to establish a theory of probable cause, test the theory to determine if it's the actual cause, then establish a plan of action to resolve an issue, implement a solution, verify our resolution of issue, and then document the solution for reference. Now, a lot of students I find, they always ask a question between 4 and 5. If we test a theory on our computer and it fixes our computer, why do we need number 5 and number 6 and 7 and 8? They get the document, right? But they don't understand why there's established a plan of action if you just fix the issue. And a lot of students don't think from the mindset of a big organization. So if you have a problem that you notice on one machine that most likely will be replicated across 100 machines, if you test a theory and you fix it on one, you then need to roll it out across 99 more machines. That's why the plan of action exists, and trying to explain that. And then they understand, oh, okay, well, that makes sense. Because you're not just fixing one, you're fixing an entire organization. So it gets to be, when you start to think of it from an organizational standpoint, 5, 6, 7, 8, they make a lot more sense. So step 1 is identify the problem. This is when you start gathering your information. If you can, you try and duplicate a problem, which sometimes is the hardest part. You question the users, the people who are using the item on a day-to-day basis, and you identify whatever symptoms come from it. Determine what has changed. This is like your detective phase, right? Step 2 is researching. It's whenever the internet and Google, I like to tell my students I had strong Google foo. This is where this is the most important, and probably where our students have gotten really good at finding solutions nowadays. And so this is what probably the most hard to teach part, because you can be really good at using Google, it's a skill that's hard to teach, I find. I don't know, I guess that's what I'm trying to say. Learning how to research, because I grew up having to research in college using the library and things like that. And so I've just gotten really good at that, I guess. And that's not really a thing anymore. Students only ever go to Google or want their answers here. We want all the answers right now, and it's not always available. And so learning to research problems, I guess, is a skill that I spent a lot of time in the classroom teaching students. And I feel like it's one of the most important parts of the methodology. So your goal at this point would be to go out and find, has anybody else ever had this problem? And when it comes to computers, I would say 9 out of 10 times somebody else has probably had your problem. Unless you're a beta tester, then of course you might be on your own. And you want to find out what they did to fix the problem. And hopefully they also documented along the way. Because even me, a lot of times I'll discover that somebody else had my problem, but then after they decided that they were done troubleshooting their problem, they didn't talk about it anymore. And so those are the worst kind of search returns. Now, after you have identified your problem, you found information that somebody else has online about it. You want to find out what's causing the problem. Say your computer is no longer displaying anything. Well, you realize you've accidentally unplugged the monitor because you kicked it like I did earlier. You kicked the plug. So you're establishing your theory of probable cause. So you question things just like the obvious things. Or you consider whatever multiple approaches are necessary to make this work. Step 4 is testing your theory. So this is where it comes into the testing of going through all the different options of you found online that might solve your problem. So for me, my monitor stopped working. I knew I had just hit it with my foot, so I plugged it back in. And okay, well, we found the root cause of our problem. Determine the next step to resolve the next steps you need to resolve your problem. And if your theory is not confirmed, then we're going to establish a new one and or escalate the problem. So if you're having internet connectivity issues, as a teacher, you check your computer. Is it plugged in? Yes. Is it turned on? Yes. We still don't have a connection to the internet. So then we make a phone call to the principal or the IT or whoever is in charge in your school to find out, why we don't have internet. Or maybe you talk to the teacher next door to you. Do you have internet? Oh, no, I don't have internet. So then you realize, okay, well, it's not just you, it's everybody in the building, right? That's how you test your theory to figure out what's the cause of the problem. And then from there, you establish your plan of action to resolve the problem. Kind of going back to that teacher with no internet, how can you resolve it? Well, you contact the person who's in charge to see if they know how to get the internet working. Maybe it's out in the whole building, and on your level, there's nothing you can do. And so you're just waiting for it to come back. I know nowadays with the way everything is online, those days when we didn't have internet in the building, it was a real problem. That's when the coloring sheets come back out. But when it comes to, like, for instance, my monitor not working, how are we going to solve the problem? Well, I plugged it back in. What else could occur when fixing the problem? Well, I plugged it back in, it came on, but suddenly I wasn't sharing anymore. So it caused a chain reaction of other problems as well. Step 6 is to implement a solution. So for me, on my one system, yes, I plug it back in, my monitor comes back, life is good. But when it comes to a full organization, there was an update that came out, as an example, and it fixes a possible virus. Okay, well, that's great. But you need to implement that update across the whole system. So how do you do that? And it needs to come out really soon. So that's part of the implement the solution or escalate. So you worry about how you're going to send that out across your whole organization. And then after you implement that, whatever it was, say, for instance, I plugged my monitor back in. I verified all the system functionality. We verified I was able to share again. And then everything kind of works or should work as you expect. And you make sure it's fixed. When it comes to the system update across the whole organization, once the system update's pushed out, you might be safe from that particular virus, but has that update caused any issues with any software that someone uses or hardware that someone uses? So then you're verifying system functionality, and if it's a huge organization, right, and you're not all in the same building, you're waiting for information to come back from users to say, hey, this doesn't work anymore. It worked yesterday, but now suddenly it doesn't work because you rolled an update out overnight while they weren't in the office. And so that's when step 8 comes in, where you document findings. So you know that there are people in a different building, in a different state, that when they got the update, their hardware that's slightly different from everybody else's suddenly had issues. And you document that so that next time you know to look out for it. And this helps people in the future who, if you don't work there anymore, also know about the issue that might pop up. Or like for me, now I know if my monitors get disconnected, I'm not sharing anymore in the middle of a presentation. So I'll be very careful not to kick the power cable. man, it's not too good whenever we have to use ourselves as an example over and over. And this is just another funny cartoon that's in the it's actually in one of the labs, or not labs, but PowerPoints. And it talks about how if you um, know how to do everything, you can put one of these next to your computer, and now you're the person that can fix everything. So if you've never seen any of the um, comic strips or panels from XKCD, they're worth taking a look because a lot of them are really funny. And this one in particular, because of it speaks to the IT repair thing. So if you have this flow chart, you can just keep it next to your screen, and you can ask the important questions. And once you get through these questions, you'll know whether or not a computer is fixable or not, or if you need to pass it on to somebody else. It's pretty good. Okay, so now that we have our troubleshooting methodology, let's try opening up a lab. Or I'm sorry, keep calling them labs, but they're actually scenarios. And I should have a scenario open. Perfect. So this is one of the first scenarios in the curriculum. It's called computer not starting. The problem here is that Liam Bowman tried to turn on his computer, and the computer appeared unresponsive. He said it was working when he left yesterday. This is very stereotypical. But now it was warning him that an update could occur overnight. He says he needs a new monitor as it's over 4 years old and it has dead pixels all over. So not only is his computer not working, but now he also wants a new monitor. So what questions do you have for him? What would you ask him to help you get the information you need for this to work, right? Like when you left, did you do anything special when you came in? Did you smell anything weird? Did you see anything weird? And then when you test this computer to make sure it isn't turning on, it does not turn on. So they're telling you right now that whenever you did try and turn it on, nothing happens. And so we talk about what information we've gathered, and we're going to write this under our identify the problem section, right? So researching, when we research a computer that says it has no power, it brings up the following. We verify the power button has been pushed, doesn't do anything. We check for disconnected cables. We're going to try a new power supply cable. If it's in a power strip, you try plugging directly into a wall outlet, or you try a different outlet. If all these things work, we check the breaker in the building. We check a new power supply. We check the power supply voltage, try a new power supply, or replace the CMOS battery. These are the kind of research things for a computer that has no power. And then we talk about some theories. So what could be the cause of this? Maybe a theory a student might throw out is that the power supply is bad, or that he needs a new power strip because the power strip stopped working. Maybe it was struck by lightning overnight, right? These are some possible theories. So now these are some theories that we'd like to test. So is there a particular theory that somebody wants to try first? And even Jess, you're welcome to say, I don't know if you've actually tried this yet. I know I shared it with you, but you're welcome to just name one if you want. Sorry, my throat is now starting to get a little dry from all the talking. Okay, check cables. So what I'm going to do, the way this particular PowerPoint works is if you click one, it'll take you to that, that slide. And then there's an option to click on and it takes you back to this testing theories. So let's click check cables. It says we check the cable, it's attached to the power supply, make sure it's not loose. We verify it's properly connected to the power strip or the wall outlet. If we have a second power cable, we could try it instead. But none of these things worked. They even tried changing the power cable and it's still not turning on. So we're going to go back to our theory testing. Anybody else want to try one? How about we try a new monitor just to see? Okay, so we bring a whole new monitor in. We plug the monitor in. It does not turn on, and the computer still does not turn on. Well, that's kind of weird. We notice the monitor's light does not even turn on. So that tells me there's no power going to the computer from the outlet, right? If the monitor doesn't even turn on. So what if we try a new power strip? You bring a new power strip, plug it in, the computer still does not power on. So that's kind of weird. So I would say we can try and plug directly into the wall, but we already know that the power strip's not doing anything. The monitor's not coming on. So what if we try a different power outlet? The computer turns on. So that's kind of weird. We already checked the other wall outlet and we checked the breaker. The breaker tripped and we flip it back on. If the problem continues to occur, we might have a faulty power strip or we need to call an electrician because it might be a little more complicated than that. So the dead giveaway was the monitor. Whenever we brought a whole new monitor in and plugged it in, it did not even light up. And that kind of tells us that there's no power coming from the wall even because our power strip, a lot of times power strips have lights on them, but the power strip wasn't even lighting up. Nothing was happening. So something happened, whether it was whenever like it got a lightning struck or something like that or whatever, who knows? But there was something that had a power draw too much for the outlet and it caused the outlet to the breaker to trip. Now, this particular lab or scenario is very near and dear to my heart because as an IT person doing tech support, a lot of the secretaries would have heaters under their desks in the same place their computer was plugged in, and it would trip the circuit breakers in the closet. And we'd have to go and turn them back on. And they always wondered why. And we got a lot more of these calls in the wintertime than we did in the summertime. And it turned out that the heaters, plus the computer, plus the monitors and printers, especially if a printer was running a big laser printer at the same time as a heater, it would cause the breaker to trip. And so that's why this one is particularly funny to me about the breaker. So I've noticed that sometimes teachers will also have heaters under their desks, and I've always kind of wondered if anybody has ever lost power from having a printer, computer, heater, space heater, or whatever, all going at the same time. But some of the ladies at the office I worked in had like big heaters. So these just kind of all go, like if you hit this one now, we do fixed, it takes us to the last slide on the whole thing that talks about documenting our findings. So it says the system now works. We can do document the findings section and answer the following. We talk about why it wasn't powering on. It was because of the circuit breaker on the wall. And then which steps should not have been attempted until checking the outlet breaker. Really, a lot of things. We might not should have tried a whole new monitor. The power supply was kind of unnecessary because one of them talks about changing the power supply out because we could have just checked from early on to see there was no power coming to the actual computer. And the steps to fix this were check to see if there was power going to the computer, reset the circuit breaker. Okay. I'm sorry. I guess I should have put this slide up earlier. This just comes from that scenario, computer not starting area. Hopefully that makes sense to everybody. I sent you a message earlier, Lakeisha. They did say that they checked and you should have access to this IT fundamentals course now. If you didn't get the message, you can check and it should work for you. You should be able to access it.